All right, here's where we ended up. We had this function, and we had had it on Desmos and zoomed out to get it. There was your relative max, your relative min. You had increasing in this direction. Okay, it's increasing in this way. It is decreasing here. There's your relative max. Decreasing to the relative minimum. And then increasing again. So that was on the last one. And now we are looking at end behavior, another way to analyze graphs. It says this is what the graph does when. This is saying x approaches infinity, when it means x is getting larger and it's going out forever. Okay, in that direction. And when x approaches negative infinity, this means x is getting smaller and it's going out in this direction along that line. Okay, as x is going more negative and more negative and more negative. Okay, that is the end behavior, what it does on the end of the graph, quote unquote. All right, we'll detail them in another few slides, but for right now, if you have an even power, so you've got x squared, x to the fourth, any even power, the ends go the same way. Okay, up or down. Okay? Actually, 6, no. That's 8. X to the 8, rather. If you have an even power. If you have an odd power, the x cubes, the x to the 5th. That x to the 6th is x cubed squared. They're going to point in opposite directions. One's going to be pointed up, and one's going to be pointed down. In both situations, an up and a down. That is the first rule to know. Okay? The second part's easy for the even powers, but it takes a little thought for the odds. Okay? Because right here I told you they both point up or they both point down. So it makes it real easy when we're going to actually write a rule. After you know the degree and whether it's even or odd, then you can look at what the end behaviors are doing. That's determined by the leading coefficient. That is that's the coefficient that is with the highest degree variable. For even powers, if the leading coefficient is positive, they will point up. If it's negative, the ends point down. If you have an odd power, the ends point in opposite directions, so you need to know how to determine which is even and which is odd. And that is getting ready to explain what I mean by that, not power. I always think back to finding the slope of a line when I'm figuring out the end behaviors of an odd function. If you remember slope, this was positive slope, and it went from positive positive to negative negative. Positive over positive is positive. Negative over negative is positive. So that would be the positive one of this, the positive quote unquote slope. So you'd have it pointing it up in this direction and down in this direction. It's going to follow the slope of a line. This one is going to be a negative slope coming in this direction. This will point up and this will point down, going in the negative direction. Okay? You can see my little arrows match together, negative and negative. So, if I'm trying to figure that out, according to your coefficient, your leading coefficient, and that's where we're talking about the negative part, not the power. I'm talking about negative 3 x cubed type thing would look like this, whereas a 3x cubed would be graphed like this. So that's where I'm talking about a positive slope. It's not really a slope, but it follows in the same situation because that's an odd power too. But that's how I always look at it if I'm trying to figure out which way it's going. All right, the next slide is going to tell you all about this thing. You'll probably want to leave it up on your notes and just copy down what it's got. X is getting larger and larger is written in this way. X approaches infinity. If it's getting smaller and smaller, it's written X approaches negative infinity. Y is getting larger and larger is written that this P of X approaches infinity. And Y is getting smaller and smaller is written as the function P of X is going to negative infinity. So when you look at that slide, this is what these things are saying. All right? Right here, you've got a positive coefficient and an even power. So you're going to have two things pointed in up direction. So this says that as X is getting smaller and smaller, approaches negative infinity, the Y is going up. It's getting larger and larger. As X is approaching the positive infinity, then Y is also approaching positive infinity. If your first one here is negative, if that's negative, and it's still even, then it's going to point down. Okay? As X approaches negative infinity, P also approaches negative infinity. So for P of X, this is negative infinity going down. For X, this is negative infinity going this direction. For P of X going up, that is positive infinity, and X going in this direction is positive infinity. So, in this case, as X approaches positive infinity, your P of X is still approaching negative infinity. Works the same way here, negative infinity and positive infinity and negative infinity. So in this case, you are going from 1 to 3. So in this situation, your A is positive. It's an odd because they're going in different directions. And you've got, as X is going to positive infinity, Y is also going to positive infinity. As X is going to negative infinity, Y is also going to negative infinity. These two are opposite. As X is going to negative infinity, Y is going up as positive infinity. On this one, as X is going to positive infinity, Y is going to negative infinity. Okay, so you can match it up if you want to mark your infinities. You can match up the direction of where they're going right there. But this is your slide that puts it all together for what's happening to the end behaviors.